In this problem, we are revolved around the line x equals -2, so we're revolving around something left of the y-axis. And so coming up with the reflected shape is really important. If the graph heads up to the right, then the graph will head up to the left until it meets the line coming down, so our reflection will have the same property. And so the part that I'm shading on both sides forms this 3D volume with a hole cut out of the middle and an outer circle in blue. And so that means now our inner radius, little r, will be going from x on the right over to x equals 2. However, since we don't really know the equation of this new curve, we're going to instead use the original functions and go from the same graph in quadrant 1 over to x equals 2. And for our little b, our little r, and our big R will be from the x on the right also all the way over to x equals -2. So we just have to figure out what is the dimension of little r and what is the dimension of big R. Well, we've previously found these equations solve for x as x equals y minus, or 8 minus 2y, and x equals y squared. So our little r will equal the y squared minus -2, and the big R will equal 8 minus 2y minus -2. Both of those can be simplified a little bit to y squared plus 2 and 10 minus 2y. And so then our integral will be the area of the concentric circles again, where we have pi times big R squared minus little r squared. So I'll factor out the pi. Big R again will be 10 minus 2y all squared minus my little r will be y squared plus 2. dy, because we are slicing vertically or horizontally this time, and our integration will start at 0 and will end where the two graphs cross at y equals +2. That would be the volume. If you're a shell method whiz, you could check your answer with what I'm circling in blue. But notice it's got two different integrals, so it's kind of a pain. And the AP board doesn't explicitly recognize teaching of that method, so I would just stick with the washer method.